This question is, differentiate a, x cubed plus 4 all times the square root of 2x plus 4, b, x to the 4 minus 2x all over x minus 3, and c, x squared plus 2x all over x root x. Simplify your answer in each case. So a. I often find it easier to let y be equal to my thing, and then I can just write dy on dx, which is a little simpler. So y is equal to x cubed plus 4x times the square root of 2x plus 4. Alright, well I've got two things multiplied together, so that means I need to use the product rule. So dy on dx is equal to the first thing, x cubed plus 4x, times the derivative of the second thing, 2x plus 4, plus the derivative of the first thing, so the derivative of x cubed plus 4x, times the second thing, square root of 2x plus 4. Okay, so let's find out what those little derivatives are. D on dx of the square root of 2x plus 4. Well, 2x plus 4 square rooted is really 2x plus 4 to the half. So when I differentiate, I'll put the half down here. So half of that thing to the minus a half, and because of the chain rule I'll have to multiply that by the derivative of what's inside there, so times 2. So that comes out to 2x plus 4 to the minus a half, which is really 1 over the square root of 2x plus 4. And the other bit, d on dx of x cubed plus 4x, well, that's not hard because I can just differentiate those two terms separately. 3x squared plus 4. So my answer is that dy on dx is equal to x cubed plus 4x times the derivative of root 2x plus 4, which is 1 on root 2x plus 4. So we get this, plus 3x squared plus 4, because that's the derivative of x cubed plus 4x, times the square root of 2x plus 4. Well, I could probably maybe make that slightly simpler by putting them over a common denominator and hoping that various things cancel out, but I haven't got any minus signs, so I don't think that it's going to get any simpler if I do that, so I might just leave it there. Right, let me start a new page. Before I do that though, I should probably mention that it was probably not completely necessary for me to calculate those little derivatives separately on a new line. I just seemed a little easier this time because of the square root. Normally you can just write those derivatives straight in if you want to. Right, let's do part B now. B. Y is equal to x to the 4 minus 2x over x minus 3. Well, that looks like the quotient rule to me. So the quotient rule says I do the derivative of the top, which is 4x cubed minus 2 times the bottom, minus the derivative of the bottom, which is 1, times the top, which is very like your product rule, only with a minus in it. But this is all over the bottom squared. That's the quotient rule. So this I can simplify because I can expand out the top line. So we get 4x to the 4 minus 12x cubed minus 2x plus 6 minus x to the 4 plus 2 to the x over x take 3 squared. I'm not going to expand out the bottom line because most of the time with fractions you're interested in whether the bottom is 0. I can tell that now. The bottom is 0 exactly when x is 3. If I expanded it out it wouldn't be so obvious, so I'm going to leave it like that. So let's see, we have 4x to the 4 minus 1x to the 4, so we've got 3x to the power of 4 minus 12x cubed, there's no more x cubed, so minus 12x cubed, minus 2x plus 2x cancels out, plus 6 all over x take 3 squared. And I don't think I'm going to be able to divide any more of those out, so I'm going to stop there. The next one is C, y is equal to x squared plus 2x all over x root x. Now that looks like it's probably the quotient rule again, but I reckon I can cancel out some x's before I do anything else, and it will make my life easier. So I've got an x on the bottom and an x squared on the top and a 2x on the top, so if I divide top and bottom by x I'll get x plus 2 over root x. And it seems to me that the quotient rule is still going to be too messy, so I think I should go x divided by root x would be root x, and 2 divided by root x would be 2 on root x. So that's just x to the half plus 2x to the minus a half. So now I can find my derivative. dy on dx is equal to half of x to the minus a half plus 2 times minus a half x. So I take 1 off of minus a half, so I get minus 1.5, so minus 3 halves. So I get a half of 1 on root x minus, and those 2 cancels with the half, 1 on x to the 3 halves. So that would be 1 on 2 root x minus 1 on, well, I guess that's x times, so that's x to the 1.5, which is x times x to the half, which would be x root x. Now this one, I reckon it's worthwhile putting it over a common denominator. So if I times this one top and bottom by x, I'll get 2x root x. And if I times this one top and bottom by 2, I'll get this. So I've got x minus 2 over 2x root x. So that's the end of the question.